I think we're almost there. We're almost there. We are there. All
Almost,
right.
almost there.
We are there. I just want to make sure it comes up over here on this little monitor here.
I'm
So,
actually,
welcome everybody to another week of Let's Go. This week we have an awesome guest. But first, I want to just reintroduce myself. I am Aaron. I am a gopher, work for Microsoft. We have our amazing co host, Jennifer. Introduce yourself. Tell everyone who you are again.
Hi, I'm Jennifer. I am a coworker of Aaron's doing awesome things in the open source side of stuff. And I'm super excited to be here because Aaron is another one of our fabulous coworkers who is also up in Canada. So he has awesome things to share with us. And if you've ever been to any of the events up there at the reactor, you might have seen Aaron, because he's just so fabulous doing all kinds of things. You want to introduce yourself, Aaron?
hello. So I'm Aaron Wislang. I'm a cloud advocate on the open source engineering team, working with Aaron and Jennifer. I do a lot of work with all things cloud, open source, cloud native, particularly Go, Python, containers, Kubernetes, and things like that. And
Nice.
based here in Toronto, I'm looking forward to the stream.
Yeah. So we are all coworkers. We have the two Aarons this
The
week.
two Aarons.
Uh,
Which
so
Aaron do you want to be? Are you
that I'll do Aaron S. You wanna? What do you want to be called?
I'll be Aaron W.
Okay. So I'm not gonna refer to myself in the third person. So Jennifer, this is you, Aaron S. and Aaron W. How does that work for you?
I was trying to figure out what our cool name is. It's like Aj,
Oh
uh,
yeah,
or
yeah,
or
yeah,
Ha, like if you pronounce J with a
yeah,
H sound. Ha.
aha, yeah. All right, we'll be the aha group this week.
Oh yes, even
Aha,
better.
yeah.
Ah.
Yeah, last week we did a lot of stuff around testing. We will pick up testing again, by the way. This is a special interlude for testing. But last week, if you go and check out the issue for last week, that's again, we have a repo, github/osscda/let's go stream, separated by hyphens there. That's where we keep all the agendas and all the recaps as well. So speaking of recaps, if you go to issue number 4, um, you can see the agenda for this week, and also you can see the recap from last week. And Jennifer was more than kind enough to write up an amazing recap from next week, which you can see here on my screen. Should pop up there, yeah. So we've got a recap, a couple of links of what we talked about. We talked about just briefly what is a unit test. We talked about how to write a unit test. And we also talked about awesome things that are going to be coming up. So we talked as well about some linters and static analysis tools. And then, of course, we talked about what are we going to do next? Are we going to write a more intense unit test? Are we going to write integration tests? Are we going to write end-to-end tests? That list goes on. So we have a lot more content to talk about with tests. Anyway, we are going to talk about something different this week, like I mentioned. We are going to talk about serverless Go, and we're going to specifically zoom in to using a product that, of course, we're all familiar with, having used Azure and working in the Azure group at Microsoft, and that is Azure Functions. So this is Azure's take on serverless, and of course, this is Let's Go, so we're going to use Go to do this. So let's start it off. Um, Jennifer, should we start off with what is serverless, you think? Or should we go a different route?
I think talking a little bit about serverless is good. I think most people understand what it is, but I think just to set the groundwork, we should talk a little bit about it.
Okay. Why don't we have our esteemed guest talk about what serverless is?
That's a good question. I think serverless is a little bit blurry for a lot of people. I mean, we think of the cloud as somebody else's computer, but and serverless not having servers, and of course everybody goes on with the joke, well, serverless does have servers. So I think from a developer point of view, we pick it up from there and we say, well, serverless is is utility build compute, basically. So I'm only paying for what I'm using, so it's very cloudy. And then it's abstracting me away from managing those servers. I think that's the two key things people want when they go serverless. We often talk about serverless in the context of functions as a service, which is what we're looking at today. But serverless isn't constrained to just functions as a service or this sort of event-driven programming model. You might have serverless containers, or you might have, as we see, these, as we're going to call them, functions, so forth.
So, okay.
What is serverless to you, Aaron? Like what it like when
Yeah.
you think serverless?
For me, I look at it as that purely utility build compute where I'm not looking to go out there and deploy a VM or deploy persistent compute that's always going to be running my workload.
Okay.
So in this case, we're looking at event-driven compute, but it's basically pay for exactly what I use, kind of down to the second or the, in this case, the microsecond.
So,
Okay, I gotta remember to say Aaron S.
yeah.
and Aaron W. I'm like, okay, Aaron S. What is your thoughts?
Well, so I actually
This
have
is going
more
to be complicated.
questions than thoughts here.
Okay, no,
So,
no, we gotta hear what's serverless to you.
okay. Okay.
Let's hear it.
Okay. I actually think I have deja vu. I feel like me and you, Jennifer, we talked about what serverless is in our cloud native one. But I'm going to try to answer this one in the context of Go instead of in the context of cloud native and Dapper. So for me, if I'm thinking about a Go app, a Go web server, serverless to me is I can write my HTTP handlers, but I don't have to do anything else. I don't have to think about like what port am I running on, or how do I figure out the TLS certificates, or what do I do about I don't know, like dealing with whether the web server failed or the port was blocked or whatever it might be. It's like all I have to do is deal with a request comes in, I deal with the request, do my cool stuff, maybe talk to the database or wherever else, then I return a response, and that's it. Because I don't have to care about where's the web server running. I don't have to care about like setting up a CDN if I've got static assets. To me, this is like write the web handler and then that's it. So I think I greatly simplified it, maybe probably to the point of like left out too much stuff. But for me, when I think about Go and serverless, that's me. That's what comes to mind, I guess.
So
But
I'm gonna just put my ops hat on, and
Yes,
this
I
is
was
gonna
hoping
be
you'd say that.
hilarious. To me, it's kind of like good and bad. And by that I mean I totally agree with the event-driven piece that you were talking about, Aaron
W.
W. But
Aaron W.
and like all of the things that you folks said, totally good. But I also think of it as there's this danger that people think it means no operations, and that's kind of silly because it's gonna run for a company. It's gonna do some stuff. And so for me, it's kind of like it's cool because I don't have to manage some of the security concerns that are underneath, and like do like OS hardening because I can depend on my service provider to do all of that stuff. That's not as interesting and might be a little bit of toil work. But I also have to think about how observable is my system? Like, how much can I dig into it? When shit goes wrong, can I dig into it? Do I know what's going on? But it's also really, really good because once upon a time, you would need like a few admin servers potentially to do a bunch of work
Hmm.
from an ops perspective. Like, I need to write a script that does a particular thing. And like, serverless is amazing for that. So, like, if I want to spin up something that will validate that all my servers are running Chef, nobody's manually turned it off and then something's out of sync, or some other check to verify something's happening. So it's like magic for an ops person to be able to like, oh, I don't have to have a dedicated admin system even running all the time. I can just spin up something when I need it. And so it's
Oh,
all the
okay.
benefits that like a normal developer, like, because ops a lot of times are developers. So we get that benefit, but then we also, it's not fun times.
Yeah. Oh yeah. When something goes wrong, right?
Yeah,
Yeah.
yeah.
Back to
I
our
wanted
definition.
to. Sorry to interrupt, Aaron. I just wanted to jump into the chat real quick. I want to say, accident. So good to have you back. Thank you for coming back. Thank you for joining us. I saw that you submitted a PR. So we will check out that PR probably after the stream because we got a lot we want to get through today. And Jennifer and I will check it out. We will answer you on the PR in the GitHub async communication style. Oh, you submitted a PR at work. Okay, never mind. Sorry about that. Anyway, thanks for joining us. It's great to have you back. Aaron W., I'm sorry for interrupting you. Please continue.
No worries. I was going back to our definition. I just remember a tweet from Kelsey Hightower a couple of years ago where he says, if you have to provision a set of servers, bootstrap a Kubernetes cluster, and then install a functions as a service platform on top before you can deploy your function, please don't call it serverless. But I think we have the programming model and we have like the consumption model. So I think that's kind of important back to what you were saying, Jennifer.
Okay. So we've got that was a both of you just made an interesting distinction. At least to me, it was consumption versus programming model. And I also heard a lot. Both of you say quite a few times. You said event driven. So I've heard this term too. An event is not just. It doesn't have to be just an HTTP request, right? There's other possibilities.
Exactly, and especially in the Azure Functions world, we have this concept what we call bindings. So, sure, as you first set up your first hello world function might be an HTTP, what we call HTTP trigger. So, our HTTP request comes in, triggers your function. It's very much like a web server and that sort of thing. But then we have this very rich set of other functions bindings, event bindings. So it might be that your function gets triggered whenever a file is created or whenever some other kind of event happens in the cloud. It could be on creation of a record in, say, Cosmos DB, which is our NoSQL database. So all of these things can effectively trigger your function. Could be a queue, for example.
Okay. So then we've got on the other side we have that consumption, and you're saying that
Can
is
we pause really quickly to
yeah.
go back to when we one of the things that we kind of miss saying there when we talk about event driven is to define events. Like we're kind of describing events, but an event is anything that you care about. It's not like an incident, right? So for my ops people, I want to just be super clear. A lot of times, events it overlaps with incidents or alerts, or like we limit it to just like event logging, a specific type of events. And so, is there anything like any technical definition that either of you would describe events more specifically as?
Let me switch to the screen with my browser up. Let's search event computer
Oh
type.
no, this is gonna be hilarious. I
Event
know
in
this is
computing.
hilarious.
An event is an action or occurrence recognized by software when originating asynchronously from the external environment. That's a little generic, huh? Events are handled typically are synchronously with the program flow. Yeah, that's a little low level. They're talking about hardware and timers. Although I understand you can have timers trigger functions, right?
That's another really good use case as well. So if it's something that effectively was a cron job before, or you might have just had it in a bash script in a loop with it all sleep in there, then you can kind of map that to what we call a timer event inside of Azure Functions. And you can even, inside our platform, you can even define that using a cron tab format.
Oh, okay. So
So it's kind of like you can
Jennifer,
schedule it. Like you can schedule a regular event. It's kind of there's also the concept of an event not happening and you want to kind of check for that, right?
Mm-hmm. Yeah,
oh,
and
okay.
you can define that as well. So in these platforms, you can say, well, do you want to catch up on events if these ones didn't happen or they come in all at once? Do you want to be able to sort of do all the ones that didn't happen, or do you want to just drop them?
Well, that's interesting. I had no idea about that. So, okay. So I have about 1,000,001 other questions. I have a feeling, Jennifer, do you have 1,000,001 other questions too?
Um,
Or are you good?
I I want to learn more stuff.
Let's
I
do it.
like I so one of the things I would be curious, I know I sort of shared some of the feels about ops, why ops people want to do serverless. Like, is there anything specific with Go that makes doing Go or serverless Go, is it better than if you were to not do serverless? Is there something there other than not managing a system?
I think the sweet spot for Go is that you can end up with very small programs, small and efficient programs. So just like when we take something that's effectively a web server and we bake it into a container and it's sort of 6 megabytes in size, as you want to sort of scale these horizontally, Go scales pretty fast and pretty well because it's a very fine-grained manner of scaling. And then once that thing is up and running, it's very good at doing the heavy lifting. It's not doesn't have some of the drawbacks of say a scripting language like Python or something like that. So it's good at both the fast scaling and the actual heavy lifting once it's running.
All right.
Oh, that's good
That
to know. So
yeah.
like limitations that you might run into with your like whatever platform you're using with like size constraints, especially overall constraints of all your serverless functions, that makes Go a really good option to choose.
Hmm.
That like that's awesome.
That's really good
That
to know. Yeah.
that and a very good concurrency handling as well. I mean, the fact that you can run a lot of these things concurrently, or your Go function can handle a lot of concurrent requests, makes it a very good fit too.
Okay. Yeah. So okay, I don't know about y'all. I have a million questions, but I agree with you, Jennifer. I want to see stuff too. So should we get into it? Some code.
Yeah, let's put Aaron on the spot.
All right.
Let's do it.
Aaron W on the spot
And
or Aaron S on the spot?
It works for me no matter
Okay.
what.
Well, maybe we'll both be on the spot because Aaron W. I've got my screen shared here, so I'm gonna follow your lead.
you'll drive, and I'll drive from the back seat. Yeah.
Yeah.
So so first and foremost, we didn't have Go on Azure Functions for a long time. So we'll take a quick look about how they landed. They're relatively new. We sort of launched them at the beginning of this year, and we're going to look for something. Well, let's do a quick Google search for Azure Functions, and then we'll just land on the docs. So is this our docs? So we'll hop into the docs there. So when you first sign up for
Oh, whoa.
Functions.
I just noticed it says more than event driven compute. More, what does that mean?
Yeah. Okay.
What is more than
Do
event
we know what
driven?
the more is?
We have some very rich functionality in functions. One of them is called durable functions, which enables you to do all sorts of very advanced capability like fan out and fan in and do all this other stuff, which we could dig into later. But we sort of take it beyond just the pure event driven as well. So that's what that's
Oh, that's a
referring
good
to.
point.
Yeah.
Like if
Durable
you're,
functions is. We should actually do a stream about durable functions because I've read like a whole. It seems like there's a whole book in the underneath in the Azure Docs about like use cases for durable and all that. We should actually cover that in a separate one and go really deep into it.
I don't know, like I think that would be good. I don't know. I think there's a whole aspect of the serverless architecture patterns too.
Mhm.
We could totally do a bunch of different streams of like what are the like Aaron was saying the fan in fan outs, all these different patterns and when to use them,
Yeah.
and how to use them. That would be kind of fun.
Let's. All right. So let's. I'm nerding out here. I want to
So
see
we'll,
some code though. Can we see some
let's,
code?
let's get to the code. So we'll
Okay.
dive into the documentation for a start.
All right.
So
It's
I'll hop
ready.
into our Azure Functions docs where we've got our tutorials and quick starts.
Okay.
And then on the left-hand side somewhere here, you're going to be able to see, let's say under Overview or Tutorials, let's just click around here. So we've got durable functions, serverless comparison, hosting plan comparison. So we talked about that consumption plan. So today we're going to be looking at functions consumption where you only pay for what you use or
So
pay
right
for each
here.
execution. But we have other plans which have more either higher scale or more dedicated compute where you can do things like mitigate against cold start, which is important for some applications and so forth. But we'll keep on clicking. So I'll click down a little bit. And what we're looking for here is a piece which we call custom handlers. So
Custom.
inside of the Azure Functions runtime, we support different languages by providing what we call a worker. So events come into our functions runtime, and then a worker tailored to the language that you are using, which might be JavaScript or .NET or whatnot, ends up actually doing the execution of that function. And it's probably on the left-hand side here. If you go down to maybe tutorials, dun, 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 or you can actually search just for Azure Functions Custom Handlers. Um,
Oh yeah.
Custom handlers, there we are, magic.
Cool. Okay.
So this is what we launched at the close to the beginning of this year, and what this enables is a Azure function to be written in any language. So Go was one of the languages we were targeting when we were thinking of this, because we had JavaScript and .NET and many others that people use functions for in Java. But this enables anybody to come along and write a piece of code which essentially handles a web request. So when an event comes into Azure Functions sort of delegates that to the piece of code, which is effectively a little web server. So today we're going to be writing a Go function, and we're going to be using that capability. And our Go application is just going to be a plain vanilla web server which can handle these requests as they're sort of shipped to it by the functions host, which you see in the middle of the diagram here.
Okay, so we've got familiar front end. That's the standard Azure Functions API. And then we've got our stuff that we write that just integrates back into that
Yep.
familiar front end. Is that right?
Yes, exactly.
Cool.
Yep.
Okay.
So,
Everything else is the same.
so if I look at this diagram, which part is the stuff that we write?
The stuff that we write, and sorry for the thing here, it's the web server up the top right hand corner.
Cool. So this blue thing, like the custom handler blue, like all this other stuff is handled by the
And
the
platform.
service.
Yeah.
Okay.
Cool.
This
So
is
as you-
yeah, I'm into this. This is really cool.
And you can probably scroll down and see some of the different functions, the different types of events that can be triggered here. So this is configured under the covers with a little bit of JSON. So as we create our function, we need to say what kind of web server is actually running, like, or what is the command to start your web server. You can see some examples there of a trigger. So if you scroll up a little bit, what we are doing is we are mapping these events which occur to an endpoint on your application, effectively on your web server. So you can see where you're going through the binding support part
Down
that
here.
we had a specific type of event
Is that this?
which had yes. So we had an event name which was this one's called myQ item, and then we have a type, so it's of a queue trigger. So we can expect that this is going to be triggered by a queue or something inside of Azure Functions. Sorry, inside of Azure at this point. This could be a service bus queue I'm expecting here, and then it's got the queue name, so the event it's going to be pulling off this queue, and then it's going to trigger this myQ item event, and we're going to write a handler which then handles that particular a trigger of that name. And then we also have the concept not only of input events, but we have outputs. So here we have when we return something from our Azure function, that can actually be put onto another queue. So you might have an input queue and then an output queue, saying maybe the status or what happened or something like that. So it's a slightly more complex example than the plain HTTP trigger. But today we'll probably start by looking at just what happens when you want to trigger something on an HTTP request.
Sweet. Okay.
So if I'm reading this, like which parts? So I see this is I'm binding an event to my application, and I want to say if there's something incoming on this messages incoming queue, I want to trigger something that I'm going to write that's called my queue item.
Yep, exactly.
And the type is going to be queue trigger. What is this Azure Web Job Storage? Is that like, what does it mean by connection?
So what this does, a queue trigger, in this case, I believe we'll be using an Azure Storage queue. So that's the thing it's going to be looking at, and it knows where to get the events from based on the connection or the connection here, which defines the storage account that it's going to connect to.
Oh, okay. So you need the connection and the queue name.
Yep.
And then that's going to be where it's listening. And then for this other one, the name return. So like what is it doing there?
So this is a common concept across functions in the sort of the functions worker model. So we have these two concepts where we have a very rich Azure Functions worker per language, which sort of you can just write the function. It has an input and an output, and the name of the output, the name of the thing that it outputs, would be called return. And this is sort of what's represented here. It's a bit of sort of a magic string or a variable, effectively. That would
Ah,
then
okay.
kind
AWS
of
has a bunch of these too. These are like
yeah.
these magic strings that you learn about as you use it. Okay.
Yes, and it's a little bit magic. Like you're coming to that for the first time, like return. Where is it coming from? Is the variable coming from my function? Is it not? So it can kind of trip people up a little bit.
Oh, so the
Yeah.
function defines what the name is when it runs. So,
Yes,
okay.
yes, and in let's say .NET or something, all of these would be strongly typed. Like you'd have an input when you get a queue item inside of a .NET function, you would get a no, an actual object which you could then introspect, and it'll be strongly typed. And then when
Mm,
you output something, that would also be strongly typed, and it kind of just maps these things to both inputs and outputs.
gotcha. Okay. Okay, cool. All right. So
So
we
are we
know.
creating an sorry, I'm just
Go
like
for it.
I'm looking at this and I'm like, oh, this is a great time to ask these questions. So are we creating a new queue here in the second one? Because it's like type queue. And
Yeah,
I'm
so that would be a new queue. That so there would be one queue, sorry, one Azure Storage account queue thing, and effectively, and you'd create multiple queues inside of that. Um,
Oh,
and
so
this,
we
and you can
have.
also do the same via service bus queues and other types of queues inside of Azure.
Oh, so this
okay.
is the. This is like. This is the bucket of queues, and then there are two queues inside of our bucket of queues here.
Yes,
So one's
yes.
coming in, one's coming out with
And
that code.
one's going out. So you've got kind of an input event and your output event, which is triggered by your function. Causes another item to be popped on the queue.
Oh, okay, I gotcha. Okay, cool. Nice.
And we might scroll down a little bit, I think. We'll explore some of the examples and see it particularly from an HTTP point of view. So what's this payload up here? If you scroll up a little bit, a request payload similar to the example is returned. So what we're looking at here is where we are creating, where we have inputs and outputs to our application with a custom handler. We don't have we have to get these from somewhere, and we don't have them for every language. If we're writing a custom handler in, let's say, Crystal or Go or Rust or something like that, that's actually going to come into our application as a JSON payload,
Mm.
and we will return a JSON payload, and this is what it looks like. So these kind of what would have been in other areas a strongly typed object. In our case, we get a JSON payload which we can determine how we want to decode or work with.
Okay. So I'm assuming this is the most important piece, but then are there examples somewhere of what we can do with all of the metadata?
Yes, so there should be in. It probably depends on the language, but if we scroll down to examples as we go down a little bit, um, might have even been up a little bit. Let's dig in straight. Oh, so here we go. We've got some examples of the payload, some documentation around the payload itself. And then we can see example for a sample payload. The best way might actually be to dive into the examples and just see how various ones are implemented. So we could look at the examples and then see where the Go ones are.
All right.
And these
Or we could like
Oh,
we could
like
start
one.
playing with one. Let's play with one.
yeah, I like that. Where
We
should
can come back to samples.
Yeah, I like that. Where are we gonna go? Are we gonna go to the samples GitHub repo?
Yeah, let's go here quickly. Let's go. Let's look at the custom handler samples repo, and we can see the different languages that we've got as examples.
Oh,
Oh,
So
cool.
R, Rust, Go. Let's dive into the Go one for a little bit.
And this is like open. Like anybody can look at these.
Yeah, absolutely.
yeah. We've got let me hop in the chat real quick. Oh, Siva, thank you for joining us again. And Eric.dev, thank you again for joining us as well. It's good to have you both back. So we are checking out I think both of you got here pretty early on, but in case you missed anything, we are checking out the Go custom handler for Azure Functions. So we just got into the code. So what's
So
first in here?
let's start by taking a look at the manifest. So the way we define, we kind of bootstrap the Azure function is through this host.json. So if we click on that, and we see that we have some JSON here, and we say that we see that we've got an HTTP worker element. That's the most important part of this whole thing, and it's got a description, and it says that we are running we have a default executable path. So it's running this binary. In order that this is effectively our web server. So whatever we run, it has to be a binary, and this says run this thing, and then you'll be listening for these kinds of events, or send HTTP traffic in its direction.
Cool. Now, does the functions runtime run this for us?
Yes, exactly.
Cool. Okay. Very cool.
So in the case of Go, we're going to have to compile our binary before we push it up to the cloud and before we push it up to the function runtime. If it was just a Node.js script or something, you'd be able to just say node server.js or whatnot.
Gotcha. Okay. Okay. So this is how should you run it? We're telling the functions runtime how should you run my worker?
Yes.
Okay. So
And we'll have a specific example of that later. We'll drop into a sample
And the version information in here, what are these different versions?
This isn't sort of needed for us right now. Azure Functions has the concept of extensions, and it kind of pulls in these things to get different events coming in, but we can sort of ignore this for the moment. The version is, I believe that's the version of the functions runtime that it's going to be using. So we're saying we're using the 2.0 version of the functions runtime. And this is one that runs on Linux specifically.
Gotcha. Okay. So I'm assuming we compile our Go binary for Linux.
Yes. So it won't have a .exe in.
Okay, cool. So back up to the code.
So we'll hop into one of these subdirectories here. So let's maybe look at an HTTP trigger, or because that's probably one. Simple HTTP trigger is probably a good place to start. So this is now, once we've set up our functions worker, we have bindings for each of the functions that we want to run. So in this case, this is what a binding looks like, which allows an anonymous HTTP request. So we've got an auth level here, which just says anonymous, so anybody can send traffic to our endpoint, our functions endpoint when it comes up. We could have this as authenticated, where we'd have to supply something on the query string or another type of authentication to actually be able to trigger it. But then we say that it's a type HTTP trigger. We've got an input binding. It's going to come in as a request, as rec, and we're defining the methods which can trigger this endpoint. So if you don't want it to be triggered on a get, you can just blop that out and say this will only be triggered on a post, maybe if it's a destructive operation or something like that. And then it's got an output binding, which is also HTTP. So basically HTTP request in and response out.
Oh, so you can have HTTP in, but output it to like a queue or something like that?
Yes. Yes. Yeah, you can be very rich in how you map these different things.
That's pretty cool. Okay. This bindings idea is starting to mesh with events in my head. It's starting to make more sense.
So let's have a look at some of the code which is in here. So you see we've got this function is in a subfolder. So the name of the function is called simple HTTP trigger because it's in a subfolder called simple HTTP trigger. And if you hop back up and you go to, let's say, the Go folder, you'll see that we have a Go custom handlers.go file, which have a really simple web server in it. There, so we got.
So how do these things glue together?
So basically this web server, we're going to compile it down to a binary, which is what the function host runs, and then the functions platform maps the requests that come back in under the name, the simple HTTP trigger, to hit an endpoint that this binary will be listening on. So if we look around here, we'll probably see somewhere where it's listening on the, let's say, simple HTTP trigger endpoint. So I'm not sure how this. Probably down the bottom. There we go. So we've got. Yeah. So all of the ones that we've created in this folder. So we've got a simple HTTP trigger would trigger this HTTP endpoint.
Okay.
The blob trigger would trigger a blob endpoint. So it's all just HTTP in and responses out.
All right. Okay, so since we haven't yet gotten to HTTP servers in our Let's Go series, I'm gonna try to boil this whole file down in like
All right.
a minute. So all right, ready? Wish me luck. All right. So
Can
first,
can I can I have a stab at this?
yeah.
Just
Please,
so
please,
I can be like I have actually learned some stuff.
please do.
I've learned some stuff.
You have learned some
Okay.
stuff. Let's hear it. Go for it.
So there's a lot of interesting things here to me. So, okay, so this is called Go Custom Handlers. But it's called Package Main at the top. So I'm really starting here at the top.
Yeah. No,
We're
that's
importing a bunch of libraries. So I see our thumped. I was watching this really cool Go in 5 minutes series this cool dude does on the internet. And one of the very first ones was like advanced, or maybe not first, but a recent one. I can't remember. I was watching it though. It was on net HTTP. So like cool. OS functions, I'm assuming, maybe some time stuff. I guess we need to actually decode some JSON. That might be good.
all right.
Then we're defining a bunch of types. So these are like additional uh, types that we are going to use, and they look kind of interesting, but whatever. Then we've got a few functions with some parameters, and it looks like we're writing a function per each of these custom handlers that we wrote little bindings for. Like we're doing like a sample per each. I guess this is like we want to say. I'm gonna I'm actually looking at it separately. I'm like going
Okay.
down. Like, let's see what this does. Okay.
Let's take. We're gonna I'm guessing we're gonna look at simple HTTP handler, right, Aaron
Where
W?
does mux come from?
Some mux down
Is it
here.
do serve mux? I guess that's HTTP.
Stands for
Okay.
multiplexer, so it's what we define our paths on.
Ah, okay. So we're defining our path here. Which one are we saying? We're saying simple HTTP. So line 210.
Mm-hmm.
And so then we just need to look at that
Specifically.
function simple HTTP trigger handler,
Oops.
which is really close to that right there.
There we
Oh,
go.
look, and we're using the time.
There you go. So this, I'm just gonna throw this in real quick. This function signature that takes these parameters and returns nothing is the required function signature for anything that you pass to handle func. So handle func literally means handle this path on my server with this handler function. That's just short for handle function. So whatever function you pass in here, whether it's trigger handler or string return value or whatever, whichever one of these, it has to have this signature. Take in a response writer, which is what you use to send a response back to the function's runtime, and a request, which is the stuff that the function's runtime sends to you, and then it's returning nothing. So that's just the important thing to keep in your mind when you're writing these handlers.
And I guess that's also the key thing from this perspective is in order to write a serverless function for Go, you don't have to know anything else except how to handle an HTTP request. So you could have just written your first HTTP handler yesterday and you can write a serverless function.
Sweet.
So when we do this, like thumped print line, month, day, year, all of this stuff, and we get the user agent from the request that comes in, so it's like understanding your web protocols, and there must be this special header that's also passed in the Azure Functions invocation ID. When we do these prints, is that actually printing to the request that's coming in, or is it not printing until it's like to the right?
So this will be printing to standard out, right, Aaron?
Yes, this one will be printing to standard out. So this will appear, just if I've got this correct, this will appear on the terminal. If we were returning it as a response, if we return it as part of the response, then it'll be in the outgoing request, which you
Oh,
can
okay.
see kind of at the end there. So
So
this
that
is
would
kind of
be
like a logging thing.
okay. So this is going to like the Azure logs that
Yeah,
only the
effectively. Yep.
admin can see. This is going back to the actual person who called the function, right?
Yes, exactly.
Okay.
Oh, okay. So can we spin this up? Is there like
Yeah.
a local test version so you don't even have to?
What we'll probably do is we'll jump from this to one which we can actually spin up in the cloud really, really quickly.
Okay.
So Aaron and I have been doing some stuff a little while back with something called Cloud Actions. So we have some repos of templates that we can spin up really, really quickly inside of Azure with the help of GitHub Actions. And I've written one of these for Azure Functions. So if we go to github.com/cloud-actions, we
Ooh.
can see
Right
the
there.
top one. Yes, we can see the
Oh
top
yeah.
one is Golang Actions Functions. Now, there's a lot of stuff in here, so don't be thrown away by some the bash scripts and the subfolders. If you scroll up, you'll see there's two things. There's an HTTP trigger and an HTTP trigger post, and there's a timer trigger. So I focused on two of the simplest scenarios, and I've written a bit more of a robust web server. There's a great GopherCon talk by somebody called Matt Ryer, who's really well known in the Go community, who talks about how he builds web services, over a period of sort of 8 years. He doesn't take 8 years to build one web service, but he has been building them this way for a long time.
That better be
And,
a
and
What
this
really
was
is
his
good
last
web
name?
server.
this
What
is
was his last name?
Matt Ryer, Ryer, and he's just I think it's Matryer on Twitter.
And if you're
And
watching this on YouTube, by the way, we'll put the link down below in the description. If you're watching it live, we'll put it onto the recap in this agenda.
but if we go into our main.go here, you'll see that
Would I go to this one?
in fact, we're not putting it in the subfolder. I think I've got a thing here. If you scroll down a little bit, let's look at our. Is there a main.go? Yep, cool. You'll see that it's a little bit more complicated than that sample. There's a few things. We're getting a environment variable to tell the functions what port we're listening on, and we're doing a few things like that. And we've created our new HTTP server. We've got a function which returns a struct. So basically, we're hanging our handlers off of this struct, and it provides some good properties around testability and a bunch of other things, makes it easy to mock. I've included some tests in here so that as you're writing your function, you can use a standard Go test to test the input and the output of your function without having to sort of build into a function, use the function's runtime, deploy, test it in the cloud. You can have a very, very tight inner development loop
Okay.
as you go through here.
All
But
right.
the key thing
Let me
here,
pause for 1 sec.
We
Okay.
we
I
could
wanna.
totally do testing with the
Yeah.
functions for
Yeah.
next time.
yeah,
Let me go a little deeper into this new
yes,
HTTP server. So I'm gonna click on it. I'm gonna go down to. Can I do this?
wow, I love how GitHub's
Yeah.
lit all this stuff up recently. It's
So we're gonna go down here. This is kind of like a constructor for our struct. It's sort of like a class in other languages. So this is sort of like we're constructing a class called HTTP server. We're then going to create a pointer to our new struct, HTTP server. We haven't gotten to pointers yet. We will. They're not as scary as they might be in other languages. But for now, just say we're making a new struct
I
with
still, it's still scary just seeing the pointer.
yeah. Like so, ignore the ampersand for now. It's not super important for this case.
Is that
Um,
so?
but
Is that a
let's.
pointer or a reference?
This is creating a pointer to an HTTP server. This
Okay,
line.
so when you use that syntax, that's a pointer.
Yeah.
It's reading a pointer here. Okay.
It's creating the HTTP server with all the stuff I've highlighted, and the ampersand is returning a pointer to that new memory, and then putting the pointer value in S, putting the address into S.
Got it. So S gets the pointer
Yep,
to this thing that's created, HTTP server.
exactly.
Got it.
So I'm gonna skip over the fields inside of it for now, because we're gonna have to go into a lot more detail on what these are. I mean, these are strings, so that's easy enough. This one is a little bit more in depth, so I'm gonna skip that for time. We are making sure we've got the right address, and then we're calling this s.routes function. So let's skip over what this function does and let's go back to main so Aaron so that you can keep going. I just wanted to sort of catch us up a little bit on what this function is doing because it looks like it's super important for the rest of the code. So keep going, Aaron. Sorry to interrupt.
No, that was good. So what we've done here is we've created a new HTTP server, and then you saw that server name in there. So generally when we create a lot of these things, if we're creating microservices or something, we're going to need to know which one of these we're hitting or which one we're working with. So we've kind of embedded this string into the struct. So now we're just changing the server name to hello gopher. So that's a value that we can get later on, just for our purposes.
So so this is the server for every one of our is this the server for every one of our triggers?
Every one of our triggers. So we've got them all on this server. And this main.go is really all the boilerplate to get a server up and running. I haven't actually included the functions themselves in this. I've just built out a template which has some of these best practices baked in. The routes function is the one which wires up some default routes. So if you did go down to routes, it's not terribly scary. It's something we've seen before, just before. So you can see that I've got a default endpoint. I've added two things in here just by default to every web server we create. There's an health Z endpoint, which is basically just one which responds, it's one you can hit to check, is my server up? Are my functions going to be responding? And you as a developer wouldn't want to be writing all these things by default. So basically you can come along and you can copy and paste this whole main.go, and then you can go off and write your own functions, which get wired up using another function which is in main.go. So if you scroll up, so you can see that I've spun up some by default, and they just like echo the name of the server, or they say is my function, is my server up, and that kind of stuff.
So where should I be looking for this?
So we'll go up to main.go. Go up to the main function.
Okay, right there.
And so this is another interesting thing which I'll dive into very, very briefly. This is as we run our web server, we have a run function which can return an error at any point. And then the main function will just spit out that error. So if you see we've got a func run and it returns an error. And that way, instead of handling each error individually, we can just say, we'll return the error, and we know that main will grab it and spit out why our thing failed. So like, let's say it couldn't listen on the correct address or something happened. So this is just a little bit of shorthand. But this is all stuff you shouldn't have to care about if you care about serverless Go. This is nothing much to do with serverless Go. So if you scroll down a little bit more, just under...
Let me interrupt again, Aaron.
Fire ahead.
Siva, are you still hearing the echo from Aaron W? I'm gonna keep going. Pop it in the chat if you keep hearing that echo. You are, okay. Let's see. Aaron, do you mind are you using headphones on your side?
I am using headphones.
Try turning
Wondering if it's coming out.
And I was muted, so
This might
It was
be
definitely me then.
Aaron W. Try saying some stuff a little on the loud side here.
How's that? Is that on the loud side?
Yeah, let's see. Siva, any improvement there? Let's see. I turned down the gain on my mic, so still yes. Oh boy. Well, we might have to roll with it for the next, let's say 10 minutes or so.
Is it really bad?
Yeah, we haven't had this problem with you, Jennifer. I'm not sure why. Usually I wear headphones, but I've been getting away with it for a while on these streams. So next time, let's see.
I just want to see if anything else is coming out from anywhere. No, I can't hear anything.
Yeah, I'll have to wear headphones next time. Yeah, I don't want to do it on the air yet because we only have 10 minutes left, and I want to get to possibly even running this, but I want to get to some more code.
I want to see it running.
Yeah, all right. So Aaron, can we skip over some of this and just see it running?
So let's just go to the thing you care about. If you go to this repository and use it as a template repository, the thing you care about, if you scroll down a little bit more, you'll see that in this main.go we're using a scroll up, still in the main.go, we're looking for the add function handlers. So what we're doing is we're passing that struct into add function handlers, and we have one Go file called functions.go, which is still in the main package, which wires up our triggers. So this is really all you have to write when you create a new service.
HTTP post and timer. Okay.
And these are really simple. We have some methods. We're getting some greetings. One of them gets a greeting and responds, and this one handles the JSON decoding and encoding for you, so it makes it simpler. This here I'm decoding it manually, but there's also one where you can sort of respond with a struct, and all of that kind of comes from your main.go.
Cool. All right. So let's try in the next 10 minutes. Let's try to get something running. You up for that?
Awesome.
Y'all?
Yes. Sounds good. Let's see if we can get you running it in your subscription, Aaron. And if that fails, you can use mine.
All right.
So let's use template. Let's use this template repo, and then we'll call it. Let's go.
It's into OSS CDA. Where are you, OSS CDA? There we go. Let's go Azure Functions.
I totally just realized this is template at the top. This is totally a template repo.
Yes.
Yeah. Include all branches? Or should I just do the main branch?
Just do the main, I guess.
Okay.
And now, in order to connect this to Azure, so what this does is this has a bash script in it, which gets triggered by GitHub Actions. It's a bash script you can run on your local machines using Azure CLI and all that kind of stuff.
Okay.
But we just need to know it's there. But in order to actually authenticate this to your Azure subscription, we're going to need to create what we call a service principal, which is like a credential for Azure. So we look inside the Azure subfolder here. So we just click on Azure because that's where we want to deploy it, and we'll see some instructions for all these bash scripts and stuff which get run, which we won't dive into right now. We just know that they know how to do the deploying. So we'll scroll down a little bit to the README. And we're going to go create a service principal. So this is just a little blob of bash that you can run either in your local terminal or in Cloud Shell. So it's shell.azure.com.
Yeah,
So don't show us that.
What's that?
Right? Don't show us that.
Don't show us at shell.azure.com.
I probably want to just do this, right? So it doesn't spit out.
Yeah. Do you have a secret? Can you? What was I going to say?
I do not. So I'm gonna just spin up the service principal and then shut it down.
Don't share your screen right now. That's what I'm
That's
saying.
a good idea. Yeah,
just do the thing, but don't show your screen.
it's a good idea.
Because this will be permanent on your permanent record.
I did put the record, yes.
Well, I can shut down the. I can delete the service principal. If
Sure. So the good thing about it,
I'm doing it with the screen turned off.
we're doing it live.
We call this the Brady Bunch view because it's three of us in the squares.
So what it does is it just gives you a blob of JSON back. If you paste this out, it's going to spit the JSON out on one line. And this will show you. But this is also very important. This service principal that we're creating a resource group inside of Azure. We're also creating a service principal, but it's only going to be scoped to that resource group. So people cannot access your entire subscription by seeing this service principal. And you can run this command a second time to actually will update the secret on that service principal. So if you just run it twice, it'll run.
Uh-oh. It looks like I have insufficient privileges to complete this operation. So...
Okay, so there's a little trouble here. This is an existing service principal. We're going to change the name of the resource group.
Oh, okay. Resource group.
Yeah, things have to be unique.
Yeah.
Globally unique. So we'll make it like 2007-00. One. This is because you and I are in the same, have access to the same set of subscriptions or in a Microsoft tenant.
All right,
So you folks can't see it because we can see it, but since Aaron's doing some secret stuff right now, what is happening is we're doing the create the Azure Service Principal. because service principals are pretty cool because you don't want to run stuff as your own user. And so Aaron S is just setting it up. And a key thing to know is you have to make sure your resource group is globally unique.
Sorry, not your resource group in this case. This is the resource groups. You can have as many inside of your subscription as you want. They don't have to be globally unique. This is the name of the service principal has to be unique within our Azure Active Directory tenant, which is another concept.
Where are you naming it, though?
I'm naming it when I go AZADSD create for RBAC, and I'm passing in a name there.
Resource group.
Yeah. So the resource group, I'm actually using the same. I'm creating a resource group, and then I'm creating a service principal with the same name. So you've got kind of a one-to-one mapping there.
Right. So when I say resource group, I'm saying this variable right here.
Yeah. Sorry. Okay.
Let me go to the chat real quick. Hey, Matei Radu, thanks for joining. Sorry about the echo. We are. It's my fault. I should have put on headphones before this stream. So. Lesson learned on my side. We will fix that next time. Apologies for that. So you were saying your resource group for the subscription as well? I mean, for the service principal.
So basically, I'm saying I'm creating a new resource group with this name of this dash variable, and then I'm also creating a service principal with that name, so that I can see it when I go into the IAM section. I can say, oh, that's that service principal that maps to that resource group, or it shouldn't be accessing this other resource group, or I can just type it in easily.
So this is using Azure CLI, saying Azure Active Directory, service principal, create for RBAC.
Yep.
And then what is this dash SDK auth doing?
The SDK auth outputs to JSON in a particular format with particular fields, the way the client ID and the secret and so forth have particular names. And then I'm saying I'm naming it, same as resource group with role here. I'm giving it contributor access, so that we can access everything in the contributor role. And then I'm scoping it to this particular resource group using that string.
Okay. All right, so I have.
It's the hardest part of the whole thing, like connecting GitHub Actions to Azure to be able to do this stuff.
All right, so I have done this in a different tab. I've copied the value, so we have
3 minutes
now on my clipboard.
So it's on your clipboard, and here's how we create the GitHub Action secret. You basically go to settings on your repo, and we're going to create it. It's like an environment variable, and we're just going to call it Azure_credentials. And this is, we have various what we call GitHub Actions for Azure. This one the one that I'm using just authenticates your GitHub action to Azure by logging in with the Azure CLI. So the Azure CLI inside of GitHub, inside of our GitHub Actions workflow, is just going AZ login, and it's using these credentials.
Okay. All right, I'm going to go back to the Brady Bunch view, and I'm going to paste this in here. There we go. All right, create the secret.
Cool.
And back to the stream screen. I keep messing those two words up. All right, so back to the screen. We've got it in a secret now.
So what we're going to do now is we're going to say this is a working, self-contained GitHub action, and this one, we won't go into GitHub Actions today, maybe we can do it on the later one, but we're just going to trigger this off. This one is triggered by commit to the repo, and inside of the Azure subfolder, I have a little file called deploy.txt, which is just a dummy file, which I switch the content from sort of ping to pong, anytime I want to trigger a dummy deploy. And it also means I can filter out all those commits after I've been testing my CI/CD system later on. So instead of like messing with the README, as some people do, they like add a space to the end of it or something.
All right, so I'll change it back to ping.
Yes.
And then I commit.
Yep. Then you commit. It would work on commit to anything inside the repository, and we even have a way to manually trigger an actions workflow now. But the thing you want to see now is you go over to the actions tab, and you'll see that this baked-in workflow is going to go out and it's going to deploy all our stuff.
So this is GitHub. I assume GitHub building the Go app and then also deploying it to Azure Functions, yeah?
Exactly. And you can see that the one that does all the heavy lifting here is under Azure/deploy-Linux. So if you open that while this is running.
It's a different action.
So you can just open it seems as though we have an error, so we do some debugging live.
What happened?
Okay, so I know what this one is. Because we're going to need to go to this file now.
Oh, this is that bash.
Yeah.
This is that nasty bash script that I created. So let's go over to our deploy_deploy-linux.sh, which I created. And this is the one which does the heavy lifting. So I'm just using actions as a bash script runner. And it's under Azure/deploy Linux.
Okay.
And this would run on your local machine. The thing we're going to need to change some variables. So I start off the script with a bunch of variables. One of them is the resource group that you're going to be deploying into. You're just going to need to rename that. And that was the third step in that. And this is exactly the same as your as the one you created.
Well, let me go back to the shell that has the secret in it, and I'm going to double check what I named it. Copy that.
So this is the deploy Linux one.
Yes.
So okay, cool. I'm actually I created an issue to update this and your Cloud Actions repo. So I'm like documenting as we go along. Like, oh, this could be better. Yay.
So
you can fix my bash anytime. My bash is not as good as my Go or other things.
All right, so we've got the name that I created here.
Clarify, this is also because Aaron had to change it because he's in the same thing. If you were cloning it yourself, you could actually have one called just whatever the default was. And you can also do things like change the location and all these other things. So it's just a bash script. And we'll just commit that. And you can actually, while that's running, we could actually have a look at the actual script for a little bit.
Oh, all right. So we're going to go back to Azure.
Okay.
Linux.
And we can see here that we've got a bunch of variables that we're reusing every time we run the different Azure CLI commands. We've also got the random string. So anything that has to be globally unique, we make globally unique by suffixing a random string at the end of it, so we don't have to worry about all that. And you can see that we're doing things like creating a storage account called AZ account create. So we make one of those, which Azure Function needs. Then we list the function that exists in the resource group. So we're making an idempotent bash script here, so that if you've run it once and it's already created your function, we're not going to try and create it again, even though that call will succeed. So that we're creating a function app. So we have the concept of the function app, which contains all our functions. We've got some flags here. We're specifically saying we want that app to be running Linux. We want it to be running function version 3. And then we're also setting some app settings, which set the extension version. We set this other variable, website mount enabled. You can ignore all this. You basically just clone and run.
I'm going to rewind that because that was like, brrr.
Yeah.
Okay. So function app is specific to Azure, and it's a way we group sort of functions, right?
Yes, exactly. So one function app contains multiple functions, and every time you create a new function, you just say, what function app do you want to run it on? And this is the stage where we decide whether we want our thing to be running Linux or whether we want it to be running Windows. It's probably the most important.
Oh, awesome. Yeah,
Okay, so that's OS type is saying Linux then?
Yes. And I'm saying runtime Python here. I could probably omit that. This has nothing to do with Python. It's just that when I was creating it, I needed to supply something, and it's by default it's Python, but then you use this HTTP extension custom handlers, which just run on any app that runs Linux. So ignore that; that's extraneous.
All right.
Kind of how the software is made here.
Okay, so we're at this point. We've listed to see if it's already there. If it's not there, then we create a function app, and then we're doing some settings, and then down here is this doing some more settings of some kind?
So this is helpful because one of our endpoints, the one that does health Z, uses an environment variable called server name, which is that server name that you talked about, that we looked at briefly, and it pulls that from an environment variable. And then we can set that environment variable in the function app itself at deployment time so that we can tell what version of a function it is right down to the GitHub SHA. That we can say, this function is responding badly because actually that deployment didn't succeed and it's running the old version.
All right, so then we go down to build the actual binary here.
Yes.
And that's
Now,
something
all
we're
that
going to have
script
to
does
upload to Azure Functions. Yes.
all that does is do a go build inside a Docker container for a Linux with output for a Linux. So that we can dig into that later, which is fun too. But that just lets you quickly switch Go versions and all that kind of stuff, and makes it independent of the environment that the script is running in. And if you have Docker running on your local machine, you don't have to care which version of Go you have running on your laptop. So you can run the script just as well on your local machine as you can inside of GitHub Actions.
All right, and this is where the magic is. Yeah,
this is where the magic happens.
All right.
And all that
so I'm going to rewind a little bit. Sorry. So something you just said was really interesting to me because it came up on a previous session where we talked about how do you limit, like, do you have to care about what version of Go you're running on your system? And what was decided was, oh, you don't. But then you just said something that was interesting, running Go in a container so that you don't have to care. Is that generally how you deploy, like how you develop code is like in a container so that you can build it and make sure it runs correctly?
I do a lot of both. When I'm targeting a specific version of Go and so forth, I do use containers. Like, say, I want the latest feature, or I want to make sure I'm on the very latest version of Go, but I don't want to have to make sure that I installed it on my MacBook, for example. In this case, we uncovered a bug inside of Go where it didn't implement a specific syscall at one point during the process, and it was to do with time, if I'm remembering correctly, and I needed to drop down a previous version of Go in order to be able to deploy something to functions. That's all fixed now, but that was just a little side effect. And that was one of the things. So we have the script which, like, you can just go there and you can update the version that you're using, or you can run it on your local machine. Like, all you need now is Docker. So you don't even have to go on your local machine to actually.
So in this case, it did matter. It mattered what you had installed.
Yes, when we were testing this the very first time, we were actually testing with Windows for one that's a deploy Windows function, would have failed if we hadn't built a specific version of Go.
Oh, okay. That's good to know.
So if we look here now, the last thing that runs is it just runs a curl against the healthy endpoint for our Azure function, and then it gives us time to respond and that kind of thing, and that should fail if that doesn't think your pipeline will fail. It'll tell you that it's successfully deployed. So hopefully,
can we go to the action and see the grand reveal?
Yes.
All right.
I was about to say, hopefully this whole thing took like a fraction of the time that it took us to explain. How long did it actually take? It took 2 minutes. So yeah, so you can have a look at the logs inside of GitHub Actions.
I want to see that curl at the end.
That curl.
Complete job. Where are we looking? There we go.
Just a lot of scrolling.
There's the health Z right there.
The health Z right there. And then
is it possible for anybody to look at logs from stuff that runs?
In the public, I believe this should be public by default. So we made very sure that we don't have any secrets in our output logs, which is important. And I could tell stories about that, but I won't right now. And if we go to, you can curl that for a start, but then you'll also be able to go into your Azure portal and see all the stuff that's deployed.
Nice. So we got all the way from figuring out what functions is, figuring out what serverless is, through to figuring out how to integrate Go with Azure functions, and then through to looking at how you build an actual functions worker with Go. And now we went all the way through to actually deploying a successful Go worker to Azure functions and being able to curl it. So that's pretty awesome. I think it was worth going a little 10 minutes over our time to see this happen. So I wanted to thank you both for sticking in there for the last 10 minutes here. I want to just wrap up a little bit. I want to say thank you all for coming, joining us. Join us next week. We're going to continue talking about testing. I think we're going to probably integrate some serverless stuff with our testing, given what we've learned here today.
I feel like we can test that live.
Uh-oh. Wow. Please continue, Jennifer. Sorry about my echo.
I'm excited. Like one of the things I've been curious about is how we can like actually run stuff and like this is awesome. And especially we can just have it running in our little project repo. This is amazing. I'm excited.
Sure. Yeah, super cool. Yeah, so join us next week, 11 a.m. Pacific time, same place on Twitch. Um, if you're watching on YouTube, it's twitch.tv/ARSCHLES. That link will be below in the YouTube show notes. If you are watching on the stream, head over to ARSCHLES, if I can spell, /about. Let's Go Live Coding is right here, and there is a link to YouTube as well, and a link to the GitHub repo, where you can see basically this ticket and all the future agendas and stuff. So I also want to say thank you so much, Aaron W., for joining us, walking us through all of functions, taking us through a whirlwind tour of all of functions. That's super cool. So that's
You'll have to come back.
Jennifer, what you got?
There's more stuff we'll build, and we'll build it all ourselves.
Nice. Jennifer, any parting words?
Well, I'm curious to hear if there was anything that was like, that was an amazing thing that I learned today from either of you, especially Aaron W.
This is this the, in case you missed it, today I learned, TALICY?
Yeah, either one. Doesn't have to be both.
Okay. Well,
But yeah.
let's start with Aaron W. Aaron W, we do this thing where at the end we either say something you learned today or something in the community, Go or serverless, that you heard about or saw in the last week that has really piqued your interest, or something that you think is really cool.
That's going to take me a second.
You're on the spot.
You go first, and then I'll see if I have something in 2 seconds.
Oh, I'll go first. Is that cool, Jennifer? I go first?
That's cool with me.
All right. So I went to and gave a talk yesterday morning at Go Wave Fest. It's a Go conference, virtual conference, of course, that a group from Belarus puts together. And I watched an amazing closing keynote by Mark Bates, who is a fairly prominent gopher in the community. He was talking about basically rediscovering Go, and it kind of boiled down to 3 major pillars of his understanding of Go, how he had to kind of throw it all away and restart. He talked about it in the context of a new package that he's working on called Packager. And the point of this package is, I keep saying package overloaded. The point of this library is to package up static files on disk into the binary, into like a array of bytes in the binary. And that's a cool idea. It's been done before. But I think it's a really cool idea because it makes the files, the byte slices in your binary, it makes them look exactly like a file system. I just think that's a really cool idea, just because it makes things so simple, but under the hood that was really hard for him to do. And it just reminds me of this like saying that simplicity is hard. So that was a really cool thing I learned this week. Obviously I learned everything today. I didn't know anything about serverless before this, so I'll keep it to the in case you missed it, and the TIL is basically everything for me.
I don't know if it was exactly this week, but one of the things I've been working with Go in particular is I've been given access to GitHub code spaces inside of GitHub. So we'll have to dive into this at some point, but we can develop using a completely self-contained, containerized environment, back to what you were talking about, Jennifer. And I've actually been using your project, Aaron, to hack on stuff like this serverless function. So we might be able to pull in at a future time and say, hey, we'll put all our serverless stuff next to all our Go stuff so that we can actually debug functions live inside our browser running VS Code.
Yeah, so let's do that. let's do that in the future one too. Let's check out code spaces. That'll be a lot of fun, I think.
I would agree because I've been trying to get it to work. So,
Yeah, let's get it to work.
um, so I have a few that may be a little basic, but they are fun for me. One, I finally understand a little more why Go serverless or serverless Go is cool, and that's pretty exciting to me in terms of the thinking about it small builds compared to because it's pre-compiled. Also, some of this cloud actions and seeing GitHub actions with spinning something up in the cloud. And what we didn't do is actually, at least I don't think we did it. We didn't actually invoke it. Is it still running? Can we invoke it?
We absolutely can invoke it. And because it had a timer trigger as well, it will actually be triggering one of those endpoints on a timer too that you'll be able to see in the Azure portal. And then later on, you'll be able to see all the observability stuff which gets lit up around that, querying and looking at the logs and all of that fun stuff.
Oh, that's awesome.
And you should be able to see it in the portal as well, Aaron. You can, oh, there we are. So that's the healthy endpoint. And then I think you can just go /HTTP trigger. It'll be capital HTTP, capital T, lowercase RIGGER, if I remember correctly. Hello function. And then if you put it, just to prove this, if you put a parameter name on the end of this, and say hello Aaron and Jennifer, or
like that.
There you go. Yeah.
Just to prove that it's live. Yeah.
Oh, nice.
This is magic. But if you just go to the Azure portal, you'll be able to see the it's spun up the function, it's spun up the stuff. Maybe in the future we'll dig into.
Very cool. Okay. Yay. It's really working.
And you can do this a little bit faster, Aaron, because you get like 1 million of these free a month. So.
All right, 1 million. All right. Well, we're down to what, 999,996 left. So I think we'll be all right.
Awesome. Okay, yeah. So this has been
cool
so cool.
Yeah. All right. I think that does it for today then. Yeah, join us next week. Jennifer, I think we're gonna have a lot of fun next week with all this stuff. You think?
I think so. I'm pretty excited.
Yeah.
We're gonna have to drag Aaron back on too.
Yeah,
maybe
Aaron,
not next week.
I'm definitely open to that. Sounds good.
All right, I'll see you next week, 11 a.m. twitch.tv/ARSchless. Talk to you then. Bye.
Thank you very much.